Hello everyone, I'm representing the E16 batch. My team members are Ashley, Harshit, Pavan, Shashida, and myself, Sahil. We are mentored by Kianusha ma'am, and we did a project on multilingual sentiment analysis. Sentiment analysis is nothing but the process of analyzing digital text to determine if the emotional tone of the message is positive, negative, or neutral. Today, many big companies have large volumes of textual data. These tools can analyze and determine the author's attitude towards a topic. These companies also use sentiment analysis to improve customer care. In this project, we analyze data to understand the sentiment behind it. We start by cleaning and removing unnecessary words. Then we teach our algorithm to recognize special patterns. This is the architecture we used in our project. The first step involves collecting a set of text data labeled as positive, neutral, or negative. This data is known as the training set. The text data is then pre-processed to remove any irrelevant information or inconsistencies. This may involve steps like removing punctuation, converting all text to lowercase, or stemming words. After pre-processing, features are extracted from the text data. In sentiment analysis, these features could be things like the presence of certain keywords. The features are then used to train a classification model. This model will learn to identify the sentiment of new unseen text data. Once the model is trained, it is evaluated on a separate test dataset to assess its accuracy. We use four major modules in our project: data pre-processing, text processing, feature engineering, and model building. Data pre-processing. The project starts by loading a dataset from a CSV file using the pandas library. This dataset contains two columns, class and text. Data cleaning involves removing any null values from the dataset. Text processing. Natural language toolkit and regular expressions are used for text processing. Tokenization involves breaking down the text into individual words using natural language toolkit's word tokenize function. Stop words and punctuations are removed from the tokenized words. Feature engineering. The text data is tokenized into numerical sequences using a tokenizer, and padding is applied to make all sequences of equal length. A dictionary of words is created from the text data to understand the vocabulary size. Words are converted into dense vectors of fixed size. This step helps capture the semantic meaning of the relationship between words. Model building. A sequential model is created using the Keras library, which allows building neural networks in a simple and innovative way. Long short-term memory (LSTM) and gated recurrent unit (GRU) are the two main important algorithms used in our project. This is the image of a simple GUI we created using Flask. The required sentence is typed in the box given below and predict button is used to get the result. This is the image of how the output looks. We get the sentiment of the text entered in the box. This is the proposed main paper. These are the pictures of the code implementation. In conclusion, this project successfully implemented a sentiment analysis pipeline for text data. Beginning with data pre-processing, it cleaned and organized the dataset, ensuring it was ready for analysis. Feature engineering involved tokenization, padding, vocabulary creation, and word embedding. A deep learning model comprising LSTM and GRU layers was built using Keras to capture the sequential nature of the text data. Overall, this project provides insights into the process of sentiment analysis on textual data using deep learning techniques, contributing to the broader field of natural language processing and machine learning. This is the implementation of our project. This is the UI we created using Flask. This is the result we get.